My name is Joe Butler. I work at Intel. I'm one of the product managers here in our for experience team for IoT. And today I'm going to talk about the new library, Create, for Intel platforms. And as I was thinking about what to talk about, I realized that this Arduino Create support and this UpSquared was just released about a week ago. So, a lot of you may not know about it, so I figured I'd go through that and let me know if you have any questions along the way. I will be going back to the chat every now and then to see. So, just to kind of summarize what we released last week, there's a new developer kit. It's called the UpSquared Grove IoT Development Kit. And let me show you what that is. So it's basically it's got an UpSquared board, some sensors, a pre-installed OS. It's kind of a kit to get going, right? With UpSquared, it's a really powerful processor, so you can really do a lot with it. It's got a lot of I/O. It's got HDMI, DisplayPort, dual Ethernet. It even has like a M.2 connection, a mini PCIe, so a SATA port as well. So it's like it's basically a single board computer, right? And then with this Grove Pi Plus shield and sensors, you can do some prototyping and IoT development, and I'll show you a little bit of that today. We've also got some built-in examples, and like I said, it's got a pre-installed Ubuntu server OS that's already configured for Arduino Create, and it makes the setup really simple. So I'll show you that. So that's what this kit is. And what is Arduino Create? So Arduino Create is a web-based IDE. If you're familiar with Arduino, which most people are, it looks almost exactly like Arduino, just in the cloud. So it's all cloud-based. So you have your own instance running on AWS with all your sketches. Same examples, libraries, serial monitor built in. And the cool thing is if you move to another computer, it's all on the cloud, so it's all there. And then the new feature that's been added is that you can now basically push sketches to devices that are also connected via the cloud, so online. So you don't have to have physical connection to your device. So as you can see, for example, I've got two devices online right now. One is actually right here across from me, and the other one is in another building here at Intel. So you don't have to be physically connected to be able to develop on those. So the other feature is that with Arduino Create, let me go back. Another thing that's been added is when you want to, if you want to take your project out of Arduino Create, you can export it as a CMake file, and it'll just download a zip, and you can go develop just using the command line, or you can import it into Intel System Studio, which Intel provides, and you can do debugging and like basically performance analysis in there. So other than that, it's very similar to the Arduino IDE, and I'll get back to it in a little bit and show you how it works. So more about the libraries. So what exactly does this mean? And that's what this presentation is about these libraries in Arduino Create. So if you're familiar with the Arduino libraries, there's a ton of libraries out there, right? You can import there's like I don't know how many hundreds, right? And you can even download from third parties and add them, right? So that's a great feature that Arduino's always had. So but the way the Arduino IDE traditionally is for microcontrollers. So it has libraries that work with microcontrollers. So if you think about developing on a Linux machine, there are certain libraries that you would use that there's just not space on a microcontroller to even use that library, right? So like one good example is OpenCV. So I think there's like a kind of a very small, lightweight version or something similar to OpenCV for Arduino boards, but it's not the OpenCV, right? And so what's been added is libraries like that where it's the full library running on your Linux device that you can now develop in this IDE for. So if you listen to there's an earlier talk today about cloud connectors from one of my colleagues. So there's like some AWS and Azure libraries that were added. I'm just going to go through and show you some of the new ones. This Eclipse Bajo is new. Intel Math Kernel Library is one that Intel provides, as well as this one is for OPC UA Open 62541 and OpenCV as well, like I mentioned. And I think that's it. Oh, actually, no, it's not. There's more. Little B is a Bluetooth library that uses systemd. Emre and UPM are the hardware abstraction layers for Linux devices, and I'll talk a lot more about that. And I believe that's all the new ones. That's just kind of a summary of what's been added and what's new. I'm gonna go ahead and talk more about the Emre and UPM library. So if you're familiar with let me just go here and show you guys. This is Emre. Emre is a hardware abstraction layer. If you're not familiar with it, it's an open source project that Intel started that supports, like over 15 boards, and not just Intel based, but ARM and others. And it's really for Linux class devices to have this hardware abstraction layer to talk to like the I/O. So each board has a definition as a pin mapping, but the API is the same. So what that means is you can write some code on, let's say, an UpSquared, take it to like a Miniboard or Raspberry Pi, something else, and it would be almost completely portable. You might have a few minor changes, right? But what that lets you do is have like a common API, right, that you can then build on top of. So we've also created a second open source project called UPM. So UPM, here we go. So it's basically built on top of Emre and uses the I/O APIs for it to add sensors. So there's in Emre there's support for like GPIO, I2C, SPI, analog, PWM. So using that, these libraries then have basically a sensor library on top of that lets you kind of just import it and run it. So I think there's over 400 sensors included right now, and they're really listed by part name. So if you're looking for them, look up the part number, because that way it works across multiple manufacturers. So, and I'll show you an example of this a little later. So, okay, so that's a little bit about Emre, UPM, and that's that's the new thing about Emre and UPM is that they're now integrated into the Arduino core libs. So what that means is that if you write, let me show you an example. So if you write a command like a analog read or a digital write in Arduino, then underneath, so like here's an example. So if you say digital write, underneath what's happening is that it's actually using Emre, and that's what's connecting to the I/O on your board. So, but the beauty of it is you can still use your same Arduino APIs, but underneath it's actually using Emre. So it for any like Linux-based platforms, right, that are supported now in Arduino Create, this Emre is the layer to connect to the I/O underneath. But you can still use the same APIs that you've been using before. Just to call this out, there's Emre has something called a subplatform, and a subplatform is basically like another platform connected to your board, like an Arduino, or in this case, it's a Grove Pi that has an Atmel chip on it. And Emre can have one subplatform at a time that it can control, and you can use that to control IOs. So one scenario which I think is really cool would be if you were to take any Linux laptop, right? That's any laptop running Ubuntu 16.04. You could now connect it to Arduino Create. You could plug in an Arduino 101 as a sub-platform, or any Arduino for that matter, and use that to control sensors and LEDs and such. But you're still on your laptop, so you don't have to have a special board to make that happen. So let me go ahead and show you an example of this. So this is an example of Emre. Let me show you an example of UPM. So UPM, you would basically include the sensor that you're using. So in this case, it's this JHD1313M1 Grove LCD. And this sensor code, or this sample code, is basically lifted from the UPM examples. So there's a lot of examples out there. Sometimes you don't have to do anything. You can just copy it in. And I'll show you, how this, let me go back to my webcam so I can show you the, actually, let me go back because I want to show you how this sketch is run first. So like I showed you earlier, I have these two devices online. One is a NOC that I have right here on this desk, and the other one's a laptop in another building. I just need to switch the network real quick to get my UpSquared back online. So let me show you my setup real quick. So what I have right here is an UpSquared board with the Grove Pi shield. I've got a LCD on it, an LED, and then a rotary angle sensor, just a potentiometer, and that's what I've got connected right now. And so what's going to happen is that I've already configured this board to work with Arduino Create. So I just power cycled the board. What's going to happen is it's going to reconnect to Arduino Create just automatically, and then it's going to show up in the list as online. And once it shows up, then you can run sketches to it. So. Okay, yeah, looks like that's it. That's the up-to desk that I set up earlier. Also in this devices, you'll see when you do have sketches running, they'll show up here and you can start and stop them. So that's another thing that's new with this Linux support, is that you can have multiple sketches running at the same time, and then you can start and stop them from here. So it offers a lot more options, and also you can obviously since you're running Linux, you can do things like system calls or manage processes and kick off, other programs, right? So let me go back into the editor. Let's go ahead and select that one. So this is up to desk via cloud. And let's go ahead and pull up this example here. So we've, examples. We've created about a dozen examples for this kit, and we'll have more, more to come. So this is how you would basically upload a sketch just like you would in Arduino. Now it's just via cloud, so I need to select that board, and then upload will compile, and then push that sketch over to my board and run it. So after that, you can see at the bottom, I don't know if it's been covered by that little window or not, but it actually has a process ID, so you can go check that process ID on your board, and you can verify that sketch is actually running. So now I'll show you what that looks like here. Basically, what that did is just a simple. Apologies, I tried to get the portable webcam working, but it didn't quite work. This is just a simple hello world to the LCD, but it's pretty straightforward. Plug it in. all you really have to do in the code is define the LCD address, which is already in the example for you from the UPM library, and then run it. So that's an example there of using the UPM library. All right, I'm gonna do one more example here. So this one is using Emre. So like I mentioned before, in this case, we have to do this add subplatform because it's using this GoPi Plus that's connected to the board. But if I were connected straight to the headers of the UpSquared, then I wouldn't need that. And then it's the same API for analog read, digital write. The only difference is, if you notice here, there's an offset of 512. So that's the way Emre handles subplatforms, is they all have to have an offset of 512. So this 512 is basically corresponds to A0, analog 0, and then this LED is on D4. So I'm going to go ahead and run this, and then I'll show you guys it. What should happen is that the LED will start flashing, and the potentiometer will control the rate of the flashing. There's just a delay in here that's set to what it reads from the analog value. So nothing fancy, but it's pretty straightforward to get it going. All right. So as you can see, I got my LED flashing right here. I'll bring my potentiometer over a little bit so you can see, and I'll just start rotating it, and it should go a little faster here. So yeah. And hopefully you can see that, and hopefully the lag isn't too much, but I'll try to go a little slower. So they're just some basic examples with sensors, but given that there's over 400 sensors in UPM, and then there's tons of examples to go with it, that you really can start adding them pretty quickly. So so that's one of the, I would say, major new libraries that's included is this Emre and UPM. One of the other ones that is new as well as OpenCV, and I'm going to show you guys that one. So let me go ahead and go back to my screen here. So with OpenCV, the OpenCV is a big library, right? I mean, it's over 100 megabytes, I think. And with some of these bigger libraries, the way they're handled in Arduino Create is they're not statically linked in the cloud. They're dynamically linked on your board. So what that means is some of the libraries actually need to be installed on your target, on your board. So OpenCV is one of those. MKL is the other one. And so far, those are the only two. All the other ones are small enough that they, it links in the cloud, and then it pushes that binary over, and you don't have to do anything else. But for OpenCV and for MKL, you do have to install them on your platform first. But once it's installed, basically this OpenCV code is the same. This is I pulled this from an OpenCV example on the OpenCV website. The only modification that you would have to make is to add this Arduino OpenCV.h, which is it's just an empty file, but it lets their server know to point to link dynamically. So that's required. And then any other changes for just adding like a setup and a loop that you would do in Arduino. But other than that, this is pretty much the exact same code from lifted from their website. So this example is a people counter, and basically what that is it uses just an algorithm to detect like outlines of people, right? It breaks the frame down into a bunch of little ones, analyzes each of those, and then it figures out, okay, which one looks like a person, right? So so let me show you how that works. Now with OpenCV in particular, there's kind of a gotcha that you need to know. Basically, when you run this sketch from Arduino Create, it'll send the sketch to your board. But if you're trying to do anything to show like an image, on a display, it'll have an error because when it's run, it can't access the display server, I guess, with the permissions it has or the way it's ran. That doesn't work. So what you have to do is you have to push the sketch over, go into your board, log into your board, and run it from there. And I'll show you how to do that. It's pretty straightforward. So now with this one, I've actually got it connected to this this NUC here. So let me switch networks real quick. Okay, and let's go back to the devices and wait for it to show up. Sometimes it takes a little bit. Might need to restart it. There we go. So the other one went offline. This one's online now. So we're good to go. So let's go back to here. Let's load up that example, and then I'll show you it. Some libraries. I'll show you how that works. How you know, basically you'll upload it here, and I'll even show you what the error looks like. So you know, if you go here to the monitor. That's something I really didn't mention, but I should probably mention is that traditionally there's a serial monitor in Arduino Create, and there still is there's a serial monitor in the Arduino IDE, the offline version, and there still is one in Arduino Create. But since you're not physically connected to your device anymore, that happens through the cloud. So normally what you would do is you would say, in fact, I have an example here, right here. So normally what you would do is you would say, serial.begin, set a baud rate, and then you would, read and print, right? And that's pretty standard. But for these cloud-based devices, what you use is debug serial. So it's the debug serial method, and it's essentially the same. You would use it the same way. You just replace serial with debug serial, and that works fine. The baud rate, it really doesn't matter. I think you can set it to anything and it still works. And there's going to be a little lag because it's going through the cloud, but it works fairly well. So let me go ahead and go back here. Oops, and I'll run this, and then I'll open up the monitor, and you can see there's other things that are in the monitor too. When there's errors, you'll see that as well. So Core i7 Cloud, okay. All right, so it's compiling it, ran it. So this is the error you'll get: GTK warning, cannot open display. So that's expected. And then what you'll do is you'll go into your device, and let me see if I can get it up here. I've got a, hopefully this will work. I'm trying to share the screen of my NUC with my other screen while sharing my screen with you guys. So see if this works or not. I'm not sure. Okay, what I might have to do, because this might just be a little easier, is let me share my webcam and let me pull it over here. And I've got it up on a display right here, so I know it's going to be a little harder to see, but it's probably the easiest thing to do. So this is the NUC that I have. And if you go, all the sketches that you run are in the sketches folder in the home directory. So here's the one that we just ran, and we can see that it was it's basically a root permissions. So that's why we can't see all the details of it. But let's go ahead and get into the root user. Here we go. No capture. Did I disconnect something? Let me check something real quick. Okay, maybe my webcam stopped working or something. Well, that doesn't work, but what you would see is basically the webcam with like an outline of what people it finds. If I get that working, I'll go ahead and show you guys. But Those are the kind of some of the new changes, right, with Arduino Create, the Emre, UPM, OpenCV. Another one is MKL. MKL is really it's really a math library for doing like, signal processing or, kind of number crunching, right? So let's say you're getting like a bunch of sensor data and you're trying to do like a Fourier transform on it, and you're trying to do some analysis right there, like the edge, then you might use MKL for that, right? It's like an optimized library to speed up those multiplications and transforms and stuff like that. So that's also included in Arduino Create now, and you can try that out. Just like with OpenCV, you also have to install that one on your board. So let me show you the full list again of libraries that we have. Let me share my screen. So we've got Emre, UPM, little b that I mentioned, OpenCV, Math Kernel Library, AWS, Azure, and Eclipse Bajo, and we'll be adding more in the future. So that's kind of all I had. If you guys have any questions, let me know. Stuart's asking, where do I get the Arduino extras, for example, the agent to connect my regular NUC to Create? Okay, so how do you connect your regular NUC to Create? Okay, let me walk through that. That's a good question, Stuart. So if you go here, am I sharing my screen? Yes. Okay, cool. There's two ways to connect any NUC or other computer to Create. So the agent basically gets installed when you go through this flow. So there's a setup for the Grove Kit, which is pretty straightforward. You plug in the USB cable, you connect your Grove Kit, your UpSquared board to the internet, and then it auto configures. This other way is basically you basically have two choices. You have either you have the IP address of your device and you're on the same subnet. So if my laptop was on the same subnet as this NUC in the room, then I would choose this one, and I would enter my IP address. So, it would ask me for the credentials. So it's basically going to SSH into that machine, and then it's going to tell that machine, go download the connector, and then then go connect to Arduino Create, and you can name your device, and then you're connected. So that's one way to do it. The other way, which going back here, is let's say your device is on a different network, or it could be even somewhere else, right? It doesn't have to be in the same location. You can just enter these things in, right? And it will basically connect to your user account, and then it will go install the connector and do the same thing and let you name your device. So there's two ways to do that. The other thing that works very well is if you have a like this NUC that I have in the room, I can actually both develop and push the code to the same machine. So what you would do is you would go and you would say, if you know the IP address, instead of giving it the IP address, you give it itself. So you say I think it's 127.0.0.0, and then it would connect to itself, and then it would set up itself as a device, and you could then run your code on the same machine that you're developing on. So that's one of the other ways to do it. So there's kind of either you have a separate machine that you push code to your target, or you're on the same machine. Either one's fine. Set itself to me, new to me, cool. Yeah. Hi, will you have a presentation for you? I missed most of your presentation. Well, there's not much in my presentation, Sujit. There's a few slides. I only walk through this one, which I'll show again, which is some of the new libraries that we've added. So Emre, UPM, or the I/O and sensor libraries, OpenCV, Intel Math Kernel Library, some cloud libraries, and Paho for MQTT. This other slide here, I was just kind of explaining what we just talked about, which is there's different ways to connect to your machine. You could have a separate machine and a target machine, or you can be on the same machine. Now, actually, another option that I didn't mention is for the UpSquared board, you can actually push sketches over USB just like you would in Arduino. So the UpSquared wouldn't have to necessarily be online, but that's just for that board because it has a USB-C port that you can do that with. So yeah, I'll share these. I'll definitely do that. Thanks everybody for listening. There's actually let me show you real quick. There's actually a forum for this Arduino Crate where you can go and you can ask questions. So and I'm the moderator, so if you have any questions, just I'll be on there as well. Okay, well thanks everybody, and have a good day.